Okay, so today we're doing regression, and of course the first thing we always do every time, library tidyverse. And once you've got the tidyverse available, you have access to a data frame called MPG, which is in the ggplot2 package. So we're going to examine that. And here it is. There's a 234 rows and 11 columns. And what we're interested in is predicting a miles per gallon. I'm going to focus on the highway miles per gallon. And in particular, I'm going to focus on the way that is affected by engine displacement. Okay? So what we want to do is build a model to predict highway miles per gallon. So the equation that we're trying to build is of the form highway is equal to intercept plus slope times displacement. So highway and displacement are the two variables, and intercept and slope, those are two parameter values which we have to determine from the data. And we're going to use the function lm to create something I'll call model 1. So I want you to do that. Use lm to create model 1. So pause the video for a minute and start it again after you've used lm to create model 1, which would allow you to predict highway gas mileage depending on displacement. Okay, you're back. Let's go on. And it's very simple. Model 1 is the LM of highway tilde displacement, comma, data equal MPG. You could also use the other form in which you say highway data $, highway and data $, displacement, but it's possible just to include the argument data equal MPG, and then you don't have to bother with the name of the data frame and the $. Okay, so use summary to look at model 1. And I'll pause for a minute while I'll let you do that. Pause the video, come back when you're done. Okay, you're back. Let's go on. Here's the summary. And the things we want to see, the intercept. We can see its value right here. It's in the column estimate with the row intercept. And the slope is in the column estimate with the row displacement. Okay, so we've got the two values that we described in our equation. Okay. What are the values of intercept and slope? Well, I just told you. The intercept is 35.6977. The slope is minus 3.5306. Write down the equation. Pause for a minute and write down the equation on a piece of paper or something, or at least think of it in your head. Pause for a minute while you do that. Okay, you're back. Let's go on. Here's the equation. There's the value of intercept. There's the value of slope. And now we have a relationship between highway and displacement. I want you to use this equation to calculate the value of HWY when displacement is equal to 2 and call that HWY2. Okay, a little bit of very simple R code. Just scratch that down. Pause for a minute while you do that. Okay. So you're back. Okay, let's go on. There's HWY2. And it turns out to be 28.6365. Now, do the same for an engine with 3 liters displacement, and of course we'll call that HWY3. Okay, pause while you write the little bit of R code you need to do that. You're back, so let's go on. So here's HWY3. We have a 3 here for the value of displacement instead of the 2. There's highway 3. Now I subtract highway 2 from highway 3. And what do you get? Minus 3.5306. So this is the interpretation of the slope. Increasing displacement by 1, quote, adds, quote, the value of slope to highway. And I say adds in quotes because, in fact, it's actually subtracting 3.5306. So we're adding negative 3.5306. Okay, the data, of course, does not lie exactly on the line we've estimated. So here's a problem which will take you a few more minutes. Show this graphically using a scatter plot of highway and displacement. Of course, put displacement on the x-axis, highway on the vertical axis, and then add a smoother, that is gm_smooth with method equal quote lm quote. Okay, this is probably going to take you about 5 minutes, so definitely pause the video while you do this, but it's really important that you actually do this. Okay, you're back, so hopefully you've done that. We pipe MPG into ggplot, and then in the aesthetics we set x to be displacement and y to be highway. And we have a gm_point, and I made the points in the basic scatter plot blue. And then the smoother with method is lm and color is red. And here we can take a look at how our model is doing. And you want to see where you're doing well and where you're not doing so well. And I would say we're doing pretty well from about here to maybe about, here or so. But you'll notice that back here, for very low values of displacement, you have a lot more high misses than low misses. And out here, when you have very high values of displacement, you also have a lot more high misses than low misses. In general, you summarize the relationship between the actual and predicted by actual is equal to predicted plus residual. So here's an actual. This height would be predicted, and the residual, of course, because it's actual equal predicted plus residual, the residual here is negative, whereas, oops, sorry. Okay, so the next step is to look at the contents of Model 1 using STR. Model 1 is an object that you created in R, and anytime you've created an object in R, you can use STR to look at it. So go ahead and do that. Pause the video while you do it, of course. Okay, so I assume you've used STR on Model 1. And what is this thing? Well, it's a list. There are 12 objects, and most of them we're not interested in. The coefficients you can see here, and the residuals, that is what we are interested in. Okay, the rest of it. So I want you to extract the item from the residuals from the model and see what it is using STR. Just call it residuals. So residuals is equal to Model 1 $residuals. Okay, pause the video and do that, then come back and we'll talk more. Okay, you're back. Let's take a look. Residuals is equal to Model 1 $residuals. And then I look at the structure of residuals, and I see that it's just a numeric vector with 234 values. Now I want to take the residuals and I want to augment the original MPG data frame by adding the residuals as a column. And to do that, you just use the function cbind. Okay? Please pause the video and do that. Then come back and we'll go on. Okay, you're back. So MPG augment is cbind of MPG and residuals. So now that you've got the column residuals in the same data frame where you have the independent and dependent variables, you can do some interesting things. So I want you to create a scatter plot using that data frame, MPG underscore augment, of displacement and residuals. Okay, so go ahead and do that. It'll probably take you about 5 minutes. So pause the video while you do it, then come back, start the video again. Okay, you're back. So again, this time we pipe MPG augment into ggplot. And the aesthetics, we have on the x-axis we have displacement, on the y-axis we have the residuals. And I do a geom underscore point, color blue, and I also added a geom underscore smooth with method lm. And you notice that in this case, which will always be true for a regression, that the relationship for the residuals shows that there is a zero slope. So you see the same things kind of that you saw in the previous graph where we plotted the model in a similar thing. And you have the high misses for low values of displacement and the high misses for high values of displacement. Okay. Now I want to talk about using the predict function. Just copying numbers down by hand and putting it into an equation is kind of a crude process, and there's actually a function in R called predict to do this. And predict, basically there is one independent variable in this model, displacement. So predict requires a data frame which contains a column labeled displacement. So if you want to create a data frame containing the values of displacement and the predictions of highway. So go ahead and do that. It'll probably take you about 5 minutes. So pause the video while you do it, then come back and we'll talk some more. Okay, you're back. So I create a variable, just a normal numeric vector called displacement, and it is just the numbers from 1 to 11. Then new data is data.frame of displacement. Yeah, there's only one column, but predict requires a column. And I just called this data frame, I called it new data. So predictions is equal to predict of model1.newData. And the results will be a data frame containing displacement and predictions. Notice that we have predictions for every value of displacement from 1 to 11. These are not necessarily, they specifically are not chosen to be values which were in the original data frame of data. We don't have data for a lot of these values. We'll see what that means. Okay. So let's look at the predictions together with the real data. How are you going to look at the predictions with the real data? Well, you have to use a ggplot, but this time there's a little trick to it. You do a second g_point specifying a different data frame than you started with. So you think about that for about 5 minutes, then I'll show you how I did that. Okay, so pause the video. Try to do this. Okay, you're back. So I do a ggplot. This is the original data frame, MPG, and I do a ggplot of displacement against highway. I do a gm_point, and that gets me the basic scatter plot. Then I want to add in the projections for all of those values that were in the displacement vector. And to do that, for the second gm_point, I display a different data and a different AES. And I made the color red so that you can see that. And what do we see? Well, the interesting thing that I wanted to point out is that when you get beyond here, this was the last real data point, and it was at something like 6 liters. But we are able to create projections going all the way out to 11 liters. Well, you created projections, but remember that a linear model does the same drop every time you increase displacement by 1. And finally, when you get out here to 11 liters, you've actually generated negative gas mileage. I do not know what that would mean. Here's the point, the takeaway point from this is that do not use a regression model to predict beyond the range of data that you have observed. Okay, we've done a lot of messing around with a single quantitative variable, and now I want to look at regression with a single categorical variable. So I want you to create a model which predicts HWY based on DRV, and use the factor version of DRV. You can do this just by putting factor of DRV into the LM command rather than just DRV, and produce a table of the values of DRV. Okay, take about 5 minutes to do that. Okay, you're back. Let's take a look. So here's the model. I call this one Model 2. It's the LM of HWY tilde factor of DRV, comma, data equal MPG. In our estimates, we get an intercept of 19.17. If the factor of DRV was F, there's a coefficient of 8.9856. For a rear-wheel drive, this is F and R. F means front-wheel drive, R means rear-wheel drive, and the coefficient for R is 1.82. Now, I asked you to do a table of the actual values of DRV, and you can see that there are 3 values: 4, four-wheel drive, F, front-wheel drive, and R, rear-wheel drive. The value 4 does not have a coefficient, and this will always be true when you do a model with a categorical variable, a single categorical variable. You'll have coefficients for all but one of the values. And the coefficient for the missing one is actually to be found right here for 19. So how you interpret the coefficients, including the constant. The constant tells you the average MPG for a four-wheel drive, the omitted category, is about 19. Then a front-wheel drive vehicle is about 9 miles per gallon better. And a rear-wheel drive is about 2 miles per gallon better than a four-wheel drive. Okay, so that concludes my walkthrough of the Regression 1 notes.